All right, coming to you with lesson 6 from the beach, Miami Beach. Got the palm trees going here. This is great. So we're going to continue our discussion of trigonometry. Remember, last week we focused on the foundations and the fundamental things that you need to know for trigonometry. We're going to continue that today. We're going to talk about our special right triangles. Now, this is something you visited in geometry. You didn't do trigonometry with your special right triangles, but you did work with them. So let me just remind you of your two special right triangles, and I'm going to show you what we do with them in trigonometry. So your first special right triangle is what we call your 45, 45, 90. And if you remember from geometry, we labeled the sides of that triangle 1, 1, and using the Pythagorean theorem, we find out that the hypotenuse is the square root of 2. All right, so those are the sides of your 45, 45, 90 triangle. You also have a 30, 60, 90 triangle. Let me sketch that out for you here. There's my 90, my 60, and my 30. The sides that go on your 30, 60, 90 triangle are 1 goes across from the 30, 2 goes on the hypotenuse, and the square root of 3 goes on the side across from 60. If I ran those through the Pythagorean theorem, they would in fact work. You should recognize these values from geometry. So how do we use them in trigonometry? Well, in trigonometry, we use them to help us find what we call exact value. So let me define that for you real quick. Different color here. All right, so exact value. To find the exact value of something means we're not going to use a calculator, we're not going to have any decimals, we're going to say specifically what the value is. So exact value to me means no calculator and no decimals. So everything's going to be either a fraction or it's going to have a square root in it, and that's it. We're not going to have any decimals. So let me show you how we find some exact values of some things from these triangles. A couple quick examples and then get you guys going on your homework here. So for example, let's say I wanted to find out the cosine of 30 degrees. Well, I have this triangle that will help me do that because I can go to this triangle right here and remember from SOHCAHTOA, let me jot that down real quick. I haven't seen that since last week, but the ka part of SOHCAHTOA reminds us that cosine is adjacent over hypotenuse. So if I go to my 30, 60, 90 triangle and look at 30 degrees, the side adjacent is radical 3, the hypotenuse is 2. So radical 3 over 2, change my 3 there a little bit, would be the exact value of the cosine of 30. All done without a calculator. I don't want the calculator answer right now. I just want to be able to find the exact value. So let me show you another one here. What if I wanted to find the sine of 45? Sine from SOHCAHTOA, O over H, opposite over hypotenuse. So I go to my 45, 45, 90 triangle this time. Sine is, I can use either one of the 45s, doesn't matter which one, it's going to give you the same result. Opposite, if I use this one, it's opposite to the one. If I use this one, opposite to the one, doesn't matter, it's going to give you the same result. So the opposite would be 1, the hypotenuse would be radical 2. So 1 over radical 2. Now I want to show you something that sometimes you'll see in trigonometry, especially if you go on into pre-calc, your other teachers might show you this. That answer right there is perfectly acceptable. However, a lot of times we don't like to leave radicals in the denominators of fractions because we like to what we call rationalize the denominators. You want to make sure the number in the bottom is a rational number instead of something irrational. Again, you don't have to. You can call this 1 over radical 2, and I'm fine with that answer. But if you wanted to, what you could do is multiply the top and bottom both by radical 2, which is perfectly okay because radical 2 over itself is just 1. Radical 2 times radical 2 is just 2. It's radical 4, but the square root of 4 is 2. And then on the top, 1 times radical 2 would just be radical 2. So radical 2 over 2 is another version of that answer you might see. I'm completely fine with 1 over radical 2, it's okay. If you want to do this rationalization part and call your answer radical 2 over 2, that's fine as well. All right, you're going to see me write it as 1 over radical 2 almost all the time. All right, just so you know that. Okay, all right, let me show you a couple more here. Let's try come down here this time, the tangent of 30 degrees. All right, 30 is right here. Tangent, TOA from SOHCAHTOA, is opposite over adjacent. Opposite of 30 is 1. Adjacent to 30 is radical 3. So 1 over radical 3. Again, just like the one I did up here, if you didn't want that radical 3 in the bottom, you could rationalize this denominator. You could multiply both the top and the bottom by radical 3. On the bottom, radical 3 times radical 3 is going to just be 3. 1 times radical 3 is radical 3. So that answer is an answer you'll also see. This is how you're going to see me write it, though. 1 over radical 3. All right, let's do the next one. I got two more, then we're done here. The next one is the cosine of 60. Let's find the cosine of 60 degrees. Cosine, adjacent over hypotenuse from SOHCAHTOA, so A over H. So the cosine of 60, adjacent 1, hypotenuse 2, 1/2 is our answer there. Last one. This one's got a couple things in it that I want to just make sure you're clear on so you can do the homework correctly. I'll come up here and do it here. So this is our last example. I want to know the tangent of 45 plus 2 times the cosine of 30. So I'm mixing them together now. All right, so let's see what this looks like. Let's first find the tangent of 45. Tangent's opposite over adjacent, O over A. So 45 opposite over adjacent or opposite over adjacent. Doesn't matter which one you do, you're going to get 1 over 1 because the opposite and the adjacent are the same in that triangle. So the O over A is going to be 1 over 1, which is just 1. So you get an answer of 1 for the tangent of 45. I'm going to add to that whatever I get for an answer here. 2 times the cosine of 30. All right, let's do the cosine of 30. Cosine, A over H, adjacent over hypotenuse. Radical 3 over 2. I'm going to multiply 2 times radical 3 over 2. Now, to do that, I'll put the 2 over 1. Remember, we did multiplying fractions back in chapter 7-8. So we know that when we multiply fractions, we can just multiply across, or we can reduce first, up and down or diagonally. I can reduce these 2's out and call the answer to that just radical 3 over 1, or radical 3. So my final answer, since I can't add 1 and radical 3 together because they're not like terms, and I want the answer as an exact value, I don't want any decimals, I don't want to use my calculator, I'm going to call the answer 1 plus radical 3 and leave it like that. I know that's not an answer that you're used to writing, but that's what it means to write these things as exact values. So on your homework for this lesson, every answer you get is going to come from these triangles right here. That's all. All right, so use the triangles, use your SOHCAHTOA, find your exact values, and hopefully that's all good for you. All right?